Introduction to Statistics, Chapter 8, Sampling Distributions, Section 8.2, Distribution of the Sample Proportion. A population proportion, P, is found by using the formula P equals X divided by N, where X is the number of individuals in the population with a specific characteristic and N is the population size. Gaining access to all individuals in a population is rare and difficult, so we usually obtain an estimate for P using a sampling distribution. If a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic, the sample proportion P hat is given by P hat equals X over N, where X is the number of individuals in the sample with the specific characteristic and N is the sample size. The sample proportion P hat is a statistic that estimates the population proportion P. Requirement for using the sampling distribution of P hat to estimate P. The sample size N is no more than 5% of the population size, capital N. So that means N is less than or equal to 0.05 times the population size. Or we can use N times P times 1 minus P if that quantity is greater than or equal to 10. So one or both of these have to be true. So if one or both of the above are met, the sampling distribution P hat is approximately normal with a mean mu sub P hat equals P, and the standard deviation sigma sub P hat is equal to the square root of P times 1 minus P divided by N. So let's look at some examples. Describe the sampling distribution P hat if the size of the population is 25,000, sample size N equals 400, and P equals 0.6. If approximately normal, find the mean, mu of sub P hat, and the standard deviation sigma sub P hat. So let's first, we're going to check to see if N is less than or equal to 0.05 N or N times P times 1 minus P is greater than or equal to 10. In this case, since we know the sample size and we know the size of the population, we can check to see if N is less than or equal to 0.05 times capital N. So in this case, we substitute numbers in. We get 400 less than or equal to 0.05 times 25,000. Well, you take 0.05 times 25,000, you get 1,250. Well, 400 is definitely less than or equal to 1,250. Hence, this is approximately normal. Now, since it's approximately normal, mu of P hat would be equal to P, which in this case was 0.6. Sigma sub P hat is going to equal to the square root of P times 1 minus P divided by N. So that's going to be the square root of 0.6 times 0.4 divided by 400. And if you do the math with your calculator, you should end up with 0.024494897. Now, second, describe the sampling distribution of P hat if the size of the population is not known. But we know a sample size N equals 300 was taken, and it had P of 0.07. If approximately normal, find the mean, mu sub P hat, and standard deviation sigma sub P hat. So looking at this, we want to check to see if the sample size is less than or equal to 5% of the population size, or if N times P times 1 minus P is greater than or equal to 10. So, since N is not known, and nothing is known about the population, we're going to check to see if N times P times 1 minus P is greater than or equal to 10. So we substitute numbers in. So you have 300 times 0.07 times 1 minus P is 0.93. Multiply that out, you get 19.53, which is greater than or equal to 10. So this is approximately normal. Now we can find mu sub P hat and sigma sub P hat. So mu sub P hat is equal to P, which is 0.07. Sigma sub P hat is equal to the square root of P times 1 minus P over N. So it's the square root of 0.07 times 0.93 over 300. And if you use your calculator, you should come up with 0.01473092. Now, a third example here. Describe the sampling distribution p hat if the size of the population is 15,000, sample size is 900, and p is 0.08. Okay? So, we're going to check to see if n is less than or equal to 5% of the population. Or n times p times 1 minus p is greater or equal to 10. So, since the sample size and the population size are known, let's check to see if the sample size is less than 5% of the population. Well, if we substitute numbers in, we see that 900 less than or equal to 750. Well, we know that n is not less than 5% of the population. So since that failed, we just don't stop. Now we have to check n times p times 1 minus p. So we substitute numbers in, and we end up with 66.24. And that's definitely greater than or equal to 10. Therefore, approximately normal. So now, mu p hat is equal to p, which is 0.08. Sigma p hat, we substitute the numbers in. You have 0.08 times 0.92 divided by 900, and that should come out 0.009043107. Okay, so here's three different examples, three things to look for. Now, the fourth example, we're going to have something else to look for. According to a study done by the Pew Research Center, 39% of adult Americans believe that marriage is now obsolete. Describe the sampling distribution of p hat if you use a random sample of 500 adult Americans. If approximately normal, find the mean, mu of p hat, and the standard deviation, sigma of p hat. Well, this is approximately normal because the population is adult Americans and the sample size is n equals 500. Now let's just think about this. Obviously, is 500 less than 5% of the adult population? I believe so. You know, this is one where just can use common sense to know that it's approximately normal because the sample size is definitely less than 5% of the population. So mu of p hat is equal to p, 0.39 in this case, because it was 39% of the Americans believe. So sigma of p hat is going to be 0.39 times 0.61 divided by 500, which is 0.02181,284. Now, using StatCrunch to find probability of p hat for a sampling distribution of p hat. When the p hat distribution is approximately normal, we first need to check and make sure p hat distribution is approximately normal. Now, if it is approximately normal, you're going to open StatCrunch. You're going to click Stat in the top menu, highlight Calculators, click Normal. Enter the value for the mean. This time we're going to use mu of p hat. Enter the value of the standard deviation. This time it's going to be sigma of p hat. That should be p hat, not p with a line above it. Choose correct inequality, less than or equal to or greater than or equal to for your problem. Enter the x value. In this case, it's going to be the p hat value. And click Compute. Okay, so let's look at some examples here. According to a study done by the Pew Research, this is the same study we did earlier, 39% of adult Americans believe that marriage is now obsolete. What is the probability that in a random sample of 500 adult Americans, less than 38% believe that marriage is obsolete? Now, before using StatCrunch, you need to know different information. You need to know n, p, mu of p hat, sigma of p hat, and a probability statement. All this information has to come from this one problem. So let's gather the information first. So n is the sample size, which in this case is 500. P is the probability of success, which is 39%, 0.39. Now, mu of p hat is going to equal p, which is 0.39. Sigma of p hat is going to be the square root of p times 1 minus p divided by n. So that's going to be 0.39 times 0.61 divided by 500. So we get to 0.02181,284, which we got earlier. And now we want p hat P hat is 0.38. That's the 38%. Now, what's the probability statement? The probability statement is P hat is less than or equal to 0.38. Because remember, when you're using normal, less than is the same thing as less than or equal to. Okay, so now let's look at this problem using StatCrunch. So let me end this here for a second. All right, now over here, once again, you would open up your normal calculator. In this problem, the mean turned out to be 0.39. The standard deviation, and I would put in the entire standard deviation you get. Don't round off, because rounding will throw you off. So this is 0.0218, 1284. Okay, and we want less than or equal 0.38. Okay, if I click compute, I get 0.32331618 right down here. This would be my answer. So there's the answer for this problem. Okay, now let's take the same problem but ask a different question. Now, if I enlarge this time, according to the study done by the Pew Research, 39% of adult Americans believe that marriage is now obsolete. What is the probability that in a random sample of 500 adult Americans, between 40 and 45% believe that marriage is obsolete? Well, this time N is still 500, P is still 0.39, mu of P hat is still 0.39, sigma P hat is still the 0.0218, 1284, but now P hat this time takes on two values, 40%, 0.40, and 45%, 0.45. What's the probability statement? We're looking for P hat to be trapped between 40% and 45%, but use decimals. So now if I go back, this time I'm going to go to the top. I'm going to pick between. Now you notice the mean stayed here, standard deviation stayed. So I just want to put the lower level 0.40, the upper level 0.45, click compute, and it's 0.32034,253. Okay, so this is if you were going to use in between. And that's where we get this answer right here. Okay, now let's change the problem a little bit. And this time, according to a study done by the Pew Research Center, 39% of the adults believe that marriage is now obsolete. Okay, fine. But now the question is, would it be unusual for a random sample of 500 adult Americans to result in 210 or more who believe that marriage is obsolete? Now, once again, we need NP, mu of P hat, sigma P hat, and probability statement. Now, this problem is a little different. So I just gave you different examples with a little twist different in each one. So in this case, N is still 500, P is still 0.39, mu of P hat is still 0.39, sigma P hat is still the same. Now, this time, how are we going to find P hat? I don't see any other percentage up in the problem. You know, would it be unusual for a sample of 500 adult Americans to result in 210 or more? Okay, so P hat, we have to go back to the very beginning slides. It's X over N. Okay, so it's 210 over 500, which is 0.42. And the probability statement we want is greater than or equal to that. Okay, it says 210 or more who believe that marriage is obsolete. So this P hat is wants to be greater than or equal to 0.42. Then I would go back to my StatCrunch. This time I'm going to go to standard because the mean is the same, standard deviation is the same, but I want greater than or equal this time, and I want 0.42. Click compute, we get this answer, 0.08451354. Okay, now if I go through this, this. Okay, now, it's not unusual. It's not unusual because the probability p hat greater than or equal to 0.42 is greater than 0.05. Remember the rule for unusual. If the probability is less than 5%, it's unusual. If the probability is 5% or more, it's not unusual. Okay, so in this case, it would not be unusual because this probability was greater than 5%. And that brings us to the end of section 8.2. Once again, this chapter is a short one. Okay, spend time, read the material, look at some of the problems in the practice problems, and work your quizzes.